out there. So with that, I want to thank Matthew and invite Gabe to take control of Zoom. Gabe Youtsey serves as the CIO for, Chief Innovation Officer, not what we usually think of as CIO, for Youtsey Agricultural and Natural Resources. He's leading the California Vine Initiative, which aims to catalyze information and entrepreneurship in food, agriculture, and natural resources, working with industry, government, academic institutions, and rural communities across California. The program is aimed at creating the future of agricultural and natural resources through science and technology, growing the pipeline of young innovators, and building a collaborative food and agricultural technology innovation community across California. Gabe previously led UC A&R's and UC Davis's IT strategy team, driving programmatic, educational, and administrative projects and collaborating with colleagues across disciplines and UC locations. Before coming to University of California, he was a management and technologist strategist at KPMG, where he led regional and national information technology and security advisory projects in food, agriculture, retail, banking, software, and other sectors. And I'll just say, Gabe is a cherished colleague, always working on interesting things. He's one of those people where if he invites you to something, you don't even look at what the meeting's about, you just check your calendar. So with that, I'll turn it over to you, Gabe.
Very kind.
And we can go, and we can go a little overtime as long as anyone who needs to drop off, at the top of the hour, go ahead, but we'll go a tiny bit over.
Okay, I have a stop too, so I'll try to move along quickly for everyone's time. First of all, you can hear me and you can see the slideshow in the way it's supposed to be seen, correct?
Perfectly.
Yes.
All right, perfect. All right, so Christine gave you that introduction. I won't go too much into myself or my background. Not advancing. Why isn't that working? Okay. Just very briefly on UC A&R, we are the cooperative extension function for the UC system. We're out of the Office of the President. So we're most tightly linked with our land grant fulfilling campuses, Berkeley, Davis, and Riverside. We've got 9 research and extension centers where we do field innovation research across the state of California. Much like other states, or just our scope is slightly bigger and our organization is slightly different. So I'm going to come at this from the lens. I could talk about food, I could talk about ag, I could talk about the environment, I could talk about all kinds of things. I'm going to focus on agriculture and really the threats to agriculture as the basis for one of our strands of action here in California. And that's really the agricultural leadership that California is. We are the #1 producer of ag in the nation. And we're very unique because we grow fresh fruits, vegetables, and nuts is our primary variety of crops, over 400 varieties of different things. And because of massive challenges with labor, I mean, this is a strawberry harvest. It takes the same amount of people that it took in the early 1900s to harvest the current strawberry crop today. We've got, we have a lot of compliance challenges, and they're necessary. We have a lot of environmental issues that need to be addressed, but those also cost time and money. Water is a perpetual issue in California. We are in a desert, but we have an amazing network of water that has to be carefully managed, and it's always scarce. Increasingly, environmental sustainability of every facet must be considered. Food safety is of paramount importance, particularly in fresh food, and this summer was a terrible one for food safety outbreak and issues that cause all kinds of alarm, panic, and hand-wringing, and real deaths too. So obviously health issues. And finally, consumers are very, their preferences for what they want to grow and to eat and know about their food and where it comes from and who's picked it and all of those things are changing. At the same time, technology is advancing, both not just in California, but all over the world, in some cases faster in other places. Israel is well known for water conserving capabilities in how they grow their food. Netherlands has amazing indoor production. Robotics of every kind, such as platforms to harvest apples and other tree fruits, traditionally very difficult, are starting to make an appearance. And then things that grippers, hands that can grip a fruit. Now, I'll just note that that thing gripping a strawberry would never work. That would crush that strawberry in a second. So soft robotics that work as quickly as a human hand are wicked hard problems to solve, and they're working on those. So California, though, is a global food and ag technology leader. And when I talk about, there's all kinds of different definitions of technology, but this growing Internet of Things for the farm and the Internet of Food below it that Matt describes, and all the massive trove of data that is coming off of the digital representation of a farm, of a food system, and all the new analytical capabilities, machine learning, deep learning, artificial intelligence, that we are now using in a variety of ways to smarten up the food system, essentially. You have to couple that with genetics, and the new, of course, gene editing is of high interest as well. But if we're going to grow, use machines to harvest and to know, we actually have to do a lot of genetic work too, and horticultural work to make sure that the plants can be harvested by machines, as an example, and grown in the correct way. Robotics of every kind are being explored and tried out. Mechatronics, from drones to different robotics that either are, full. There's really not one that's fully replacing any farmer anytime soon, but there's a lot of intermediary technologies that are coming online. Connectivity, food science technology, clean energy, and scaled for small and large farm size. All of those things are technologies that are coming fast and furious at food and ag production. But the adoption of that stuff is slow. So pace of farming is on an annual cycle. It's a very slow adoption. There's lots of isolated startups. Those need integration for them to actually work well. If you go to any of these ag or food tech events, particularly in Silicon Valley, you'll hear a lot of marketing, but very dubious science. Our models to collaborate. We actually must collaborate between the government, academia, and industry for an effective rollout of these technologies on any type of a quicker time scale. Our investment models are problematic because venture doesn't work well. And it's very difficult to get these technologies into the market today for a number of reasons. So all things I'm going to gloss over for now, but just highlight some of these challenges. So we have created a new institute called the Vine Institute, built off of 4 existing California Institute for Science and Innovation model that we are going to use to collaboratively solve problems and drive the adoption of new technologies. And so our network encompasses the Youtsey system, but also the Cal State system, the community college system, the private sector, and government as well, across the state, a variety of different players and partners. This is only a small representation. And we really see this kind of collaborative model in the Vine community, we call it, emanating out from California globally, across the nation and the world. Some of the focus areas that we are where we're going to work on. I'm going to hone in on the data piece, but a farm to food data hub, which would be very complementary to Matt's Internet of Food. Various indoor agriculture systems of production. I talked about farm and robotics process automation. Looking at new opportunities for specialty crops, new crops, hemp, coffee, moringa, barley. Those are all new things that we're exploring in California, and we want to build automation into the process from day one. And one of the things that universities do well and can do well to support the commercialization of technology is test those things. Cooperative Extension does that well, and it's a key value add that we can do to accelerate the marketplace adoption of these technologies from the work we do in academia. So just very briefly, just give you a little snapshot of what one of these things looks like. This is our Kearney facility in south of Fresno, California, where we'll integrate precision irrigation. We'll fly drones. We do robotics. This is Blue River, one of the big, fantastic ag exits to John Deere recently. That's lettuce being planted. We have a wireless across the entire field, so I can watch 10 megabit, Netflix at any part of the property. And farmers come out to these properties to do field days and conferences all the time. And we have a number of different crops there, which are all connected. So one of the ways that we're thinking about how do we layer on services to support the commercialization of research, and also to support the science-driven aspect of industry is in a couple different ways. One is on the lower right, to ultimately drive towards a data hub that we would likely partner with folks like you to create, to test interoperability, to do data-driven research, to be a repository, and to support data services. And one of those data services that we have already built is a tool called Crop Manage, which I'm going to talk about, and its claim to fame on what it does is reducing the amount of water and fertilizer in production farming. All that needs to be supported by good standards. Currently, one of the most prominent, we're not using this in California yet, the Ag Gateway data standards, which are pushing towards an ISO classification, would be one of the ways that we could support interoperability. At the same time, couple that with different classes where we can actually put these technologies into the hands of growers in a fairly non-proprietary open way, so that we have a way to pass on that knowledge, a key function of cooperative extension. So I'm going to talk a little bit more about Crop Manage. So first of all, taking this approach of, we're not in the business of collecting data for data's sake. We're actually creating applications that matter to the business. So what this application that a farm advisor, Michael Kahn, a cooperative extension irrigation advisor, really sharp dude from Salinas, created this protocol, using established research-driven crop ET models, evapotranspiration irrigation models, crop N nitrogen models. And so it essentially takes in available soil and data that's already been mapped for the state of California, takes in data from this publicly available weather station. It takes in nitrate, you do a little quick nitrate test to enter those values, and other sensors from the field, irrigation and other sensors as well. And it puts that into a database and essentially spits out recommendations for how much to irrigate and how much to fertilize. There's nothing like this. There's a lot of water recommendations out there. They're not based on science. They're not crop specific. And the nitrogen is very wicked hard to complex. I can't even describe how that works, but suffice to say it is. And so it gives you a very precise management model, which regulators want, which increasingly suppliers like Walmart want, which a variety of different people want, and the farmers are, it also saves the farmers money. Now in California, where crop prices are very high, that doesn't actually mean a lot sometimes. A little extra fertilizer and a little extra water is called an insurance policy. But when they're compelled to produce the reports of all that, and they're able to use a Youtsey science-based prescription and prove that, it starts to become very, very, very attractive.
What is the...
So the way that we're thinking, we've got this model, we've turned it into software. I'm not going to show you the application right now. You can go, let's see, I'll give you you can go to the website, cropmanage.io. But the way that we're thinking about this, sorry for this busy diagram here, is really thinking about how do we abstract, we're not in the business of delivering software. Typically, anytime I ever see a research-based software platform, it's not something that Silicon Valley would produce. And we need to get it to the point where it is that. We either need to license it out, we either need to offer partner in some way. So we're thinking about it in a different way. We don't want to go and create a startup out of it, compete with industry, and then have it be bought up by Bayer, Monsanto, John Deere, whoever, and become a proprietary service. We actually want to use this as a real-time research translation capability to deliver a core service that can be consumed via API to other systems, and then kind of disintermediate some of the actual input data and task data and deliver crop manage as a service. And so we're thinking of this as a microservice now, where we can, as new different kinds of services come on, we can layer those in into a nonprofit and actually partner with industry to take those into commercial products. So what are our goals in doing this? One is we really want to enhance both grower profitability and sustainability of what they do, but also at the same time supporting our regional water and nitrogen sustainability of the communities which this product is used. We don't want to compete with industry. We want to support it and accelerate science-based tech adoption. We also want to recover costs of this, because you can't run a business on grants. You can't run a business for nothing. So we have to figure out a way to create a public-private partnership out of this, and let the growers leverage their own data and support research and innovation. We are looking to find that model where they can plug in and use their data for their own benefit, but also to partner with researchers to innovate with the massive trove of data that products like and services like crop management will produce. So, I was inspired by this. I got this phrase, translational agriculture, from a guy named Adam Wolf, who's the founder of an ag tech company called Arable. He graduated out of Princeton, but he was a cooperative extension guy in California. So you can read his entire quote there, which is a little bit down on university faculty, but I like what he said about a user-centric process that addresses the roadblocks to implementing these technology and practices. And that's really what we're after, this translational agriculture, but in a real-time fashion. So with that, I'll end it there. You can check out our Vine website. You can tweet about us or see what we're tweeting. Follow us on Twitter as well.
Gabe, thank you so much for that. Do you have time for a quick question?
Yep.
Okay. Oh, I don't have one, but well, I mean, as John said, I have many, but I mean, I want to open up for others who might not have as easy, quick access to you. Yeah. So let's open the floor for some quick questions for Gabe.
Hi, this is Jason. Can you hear me?
Yeah.
I was wondering what the resolution of the recommendations for fertilizer and water were. Is that like per plant, per acre?
That is a good question. It is that per acre, not per plant, because you could never irrigate to that level of efficiency, but it is per acre, if I'm remembering correctly. It's either at the ranch level, but I think it's actually more at the acre level. But everything is organized, agriculture is organized by what they call ranches, which are a variety of acreage sizes, and then you move down to blocks. So it typically organizes into blocks and by ranch. And that has a variety of crops, but you can get it basically down to, I think, about the, actually you can go sub-acre, because think of it about in the sub-acre level. I'm not sure, it's not down to the plant, not even down to the row, but you definitely can have multiple rows in an acre that it will manage. So
is that
probably get a more precise answer than that, but it's an acre, a little bit finer than that.
Is that at all driven by the distribution of the sensors?
So it actually doesn't actually require any sensors. I mean, it gets better with with CIMIS data is already plugged in for the region. It actually doesn't require sensors because it's model driven.
Okay.
Yeah.
I assume that model was driven from data from the field.
That model was driven by lots and lots and lots and lots and lots of data from the field, and then proved out and tweaked and retweaked. Yeah, absolutely. So they found that actually the model, the reference ET and the actual water applied, they've proved it out through trials pretty effectively. But there's some things we can do, like the nitrogen quick test. You take at a point in time, and it changes, around the field. As nitrogen sensors start to become available, we will be able to fine tune those acres into higher and higher degrees of resolution. I think at some point you will be able to get to plant level resolution, and you'll get irrigation levels at that level of resolution. It's just we're not quite there yet.
All right, thank you.
Well, and Jason, you might be aware of this project. This is, very experimental. Not Gabe's really working with people who are, doing production scale agriculture. But the TerraRef project that has the grow field in Missouri and Arizona, that does have plant level granularity, and but it's because they're trying to look at specifically how plants grow under different conditions.
Yeah,
and
so,
I believe that's terraref.org.
And there's a lot of things that are getting to that level to try to explain what happened in the field. The thing that's unique about this that would couple with that would be, here is a recommendation for what you need to do next that's driven by science. So that's one of the differences. But there's a lot of like down to the resolution, very, very plant level resolution, including plant level sensors. The networking on that's still a little challenging, and the analytics are still a little hard, but it is there.
And if I could just throw in a quick comment, something that I learned from Gabe, actually, I work, of course, I'm connected to NCSA in Illinois in the middle of cornfields, and then, of course, in California. And, you could say, we could just have one big data hub because look at this interest area, everyone cares about agriculture. But actually, regionally, there's different approaches, because California agriculture, from what I understand it, and hope I'm paraphrasing correctly, Gabe, focuses on a lot of niche crops. And so you are wanting to control things at the sub-acre level, whereas, say, in the Midwest, it's okay, granularity at just even, tens of acres enough.
Yeah, I was trying to figure out whether California and Vermont agriculture might be more similar, or whether it really is that every region, because of climate and scale, are different.
I would say climate and Vermont are very, very different in a lot of ways. Rainfall, a lot of ways. Yeah. But there are,
water management is so huge for us too, compared to probably Vermont, right?
Yeah, it is. They don't really have irrigated crops for the most part on the East Coast.
Yeah. So it really may be that every region, almost every state, is different.
Yes, absolutely. So one of the things
tools and techniques reusable, or
yes,
from the ground up?
Yeah, that's what I was going to say, was that we've built this as a platform. So right now we're getting Hawaiian crops on, which are also irrigated. But the nice thing, the way Michael's built this, and because of the way California agriculture is, we got to get lettuce on, and that's very different than tree nuts. And so we built it with a platform in mind. So we are actually planning to roll it out to South America and Africa, and create approaches to localize it in every region of the world for nitrogen and irrigation management. And we built the underpinnings to do that. We have to probably partner with a commercial industry partner or several to make that happen, but the engine is there.